this video, I'm going to go through page 6 of the ACT. This covers questions 39 through 47. If you're practicing along with this video, maybe pause here and give yourself 1 minute per problem. Not that you have to complete each problem in a minute, but it'll get you used to that timing. Or just time yourself and see how long it takes. There's 9 questions on this page, so we would be aiming for about 9 minutes, but it is later in the ACT. It's past the halfway point, so maybe a little bit more than 9 minutes. Alright, let's get started. So in number 39 says given matrices x equals -1, 0 and y equals -2, -1, which of the following matrices is xy? Now there's a lot more to multiplying matrices than what I'm going to go through in this video. This is a pretty easy example, and this is telling you to multiply these matrices, x times y, right? When things are right next to each other, it means multiply. So we're going to multiply this matrix, -1, 0, like that, which is like horizontal, times this matrix, which is -2, -1. And it's weird that we can multiply these things that are like different dimensions, or they're like going in different directions, kind of. But this, actually, these arrows that I drew, this is how you multiply matrices, kind of in this order. So we're going to do this first term and this first term, or they're actually called elements. So this element times this element, so that'd be -1 times -2. And then this element times this element, so 0 times -1, and then we're going to add those together. Now if these were bigger matrices, they could be like 2 by 2 or even bigger. It would be a lot more complicated. This one's pretty easy. So just 2 plus 0 or just 2. Now the answer is technically still a matrix, it's not just a number, but that's pretty obvious from looking at the answers. So we can see that the answer is D. Moving on to 40. It says, regardless of how the graph is oriented in the standard xy coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Which one? Alright, so what is it really asking here? I know it's talking about a vertical line of symmetry. We're going to talk about like graphing all these things, and it's saying that one of them doesn't have a vertical line of symmetry, basically like no matter what. Well, if we visualize just a coordinate plane here, an xy coordinate plane, if we draw a line like this, there's obviously no vertical line of symmetry. But if I drew a line horizontal, then there would be a vertical line of symmetry. I could cut that in half and it would be the same on the left and the right. Or I could just draw the line vertically, and then that is also a vertical line of symmetry. Obviously, a square has a vertical line of symmetry. A pentagon also does. It's a little bit harder for me to just draw nicely here, but it has 5 sides, but you can draw it, sort of. That's definitely not symmetric. That's pretty close. So yeah, there's a vertical line of symmetry there. Now, a parallelogram, usually we think of as being this kind of shape, and that does not have a vertical line of symmetry. And if you rotate it any which way, it also doesn't have a vertical line of symmetry. But a parallelogram could be a rectangle, and a rectangle would have a vertical line of symmetry. And then the last one is scalene triangle. And a scalene triangle means that none of the sides are the same, none of the angles are the same. And so I think that's the candidate, because no matter how I rotate that triangle, it's not going to be symmetric, since none of the sides are the same length. And I can get rid of this. I was just confused about J because a parallelogram kind of had 2 different cases. But here the answer is K. 41 says the equation 24x squared plus 2x equals 15 has 2 solutions. What is the greater of the 2 solutions? So this problem has kind of 2 main parts to it. First of all, we have to solve this quadratic equation, find the 2 solutions. And then the second thing is we have to figure out which one is the greater of the 2 solutions. Now there's 4 main ways of solving quadratics. Usually we try factoring first, because if it's factorable, that's the easiest way to solve it. If it's not factorable, I prefer completing the square. Some people like quadratic formula. And then there's also graphing. Now with this being a standardized test and you want to make sure you get the right answer and you kind of don't care how you get to that answer or like which method you use, I might prefer graphing here. To do that, I would get everything on the same side of the equation, which actually you're going to have to do for pretty much any method. So I subtracted the 15 over. And then that equals 0, but if we're typing it into our graphing calculator, it's going to say like y equals that. And then if we're looking for solutions, we'd be looking for x-intercepts. Now I'm not going to demonstrate that in this video, because everyone's graphing calculator functions a little bit differently, but that's the idea. And then you'd be looking for which one is the greater, or the one farther to the right. So going back to the first method, this might be factorable, But honestly, I'd have to figure out 24 times 15, which is a pretty big number, and then I'd be dealing with like numbers that multiply to that and add to 2, I think. So it's just kind of a mess. Even if it is factorable, that would be kind of difficult. So personally, I would go to completing the square next, but completing the square isn't really a good option if the a value isn't 1, so we might as well just do quadratic formula, which I wrote out right here, but most people are pretty familiar with that. So that's quite a lot to type in your calculator. Just do it carefully. You might want to pause the video here and practice just typing it in and see if you get the same answer as me. Alright, so my calculator gave me some decimal answers, which is not what I see as options here. But obviously between the two of these, I know it's not going to be this one because I'm looking for the greater solution, so I don't want the negative of the two. So I can rule that out, and 0.75 is the same thing as 3/4. Like 75 cents is like 3/4 of a dollar. So the answer must be A. 42 says, which of the following expressions is equal to sine of 60 degrees times cosine of 30 degrees plus cosine of 60 degrees times sine of 30 degrees? So I think this question is intended to be asking you if you know about your trig identities. One of these matches with this expression up here, and that's an actual trig identity. If you know that, maybe you learned it in a pre-calc class, then this question is pretty quick, but you have to have that identity memorized. And the thing is, you don't need to know the identity at all to do this problem. Since it's multiple choice and since you have a calculator available, all you really need to do is type all of this in up here, see what you get. It'll probably give you a decimal, that's okay. And then just type in each of these possible answers and see which one gives you the same value. Now it is worth mentioning that you need to make sure you're in degree mode. So make sure your calculator says it's in degree mode and then just type in exactly what you see. Now it turns out that just equals 1. And again, if you start typing all these answers in, you should see that the answer is J. 43 says, what is the area in square units of a circle that has a circumference of 12 pi units long? So to do this problem, you have to start by drawing a perfect circle, and then labeling the circumference as 12 pi. Now the equation for circumference is 2 pi r, and the equation for area is pi r squared. If you notice, both of these equations have exactly the same things in them, a pi, an r, and a 2, so it can be kind of difficult to keep them straight. One thing that helps me remember is just to think that like area, usually in units, is like inches squared or like centimeters squared or something, and so the area formula is the one that has the squared in it. Now they told us the circumference is 12 pi, so I'm going to plug that in for C, and then write 2 pi r, and then solve for r. That'll give me a value that I can plug in here, and then that'll tell me the area of the circle. So to solve this for r, I need to get rid of the 2 and the pi, so I'll divide by both of those. 12 divided by 2 is 6, and the pi's cancel. So r is 6. The radius of the circle is 6. And then if I plug that into the area formula, area equals pi times r, which was 6, squared. And that would be 36 pi. So the answer is D. 44 says, a barrel contains 25 liters of a solvent mixture that is 40% solvent and 60% water. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel, so that the new mixture will contain 50% solvent and 50% water. How many liters of pure solvent should Lee add to create this new mixture? So first of all, that's quite a lot to read and then make sense of. And then we have to calculate a bunch of stuff after that. So let's just like back up and see what we know. Okay, we have a barrel that contains 25 liters of a solvent mixture, so a mixture, so like 25 liters total, and that mixture is 40% solvent, 60% water. So here's our current barrel. Perfect depiction of a barrel. 40%, or in other words, 0.4 times the 25 liters in that barrel is 10. So 10 liters of the 25 liters is solvent, and 60%, or 0.6, of 25 liters that are in the barrel would be the rest of it, right? Because we have 100% total between these two, so that must be 15 liters. The reason this helps me, and by the way, that was water, the reason this helps me is because now I have like concrete values. I know how much solvent and I know how much water is in there. Now he's going to start adding pure solvent because there's not as much solvent in there currently. He's going to add more of that until it's balanced out 50-50. The key thing to realize is he's not going to add any water. So when it's balanced out and it's 50-50, there's going to be 15 liters of water, and that must mean there's also going to be 15 liters of solvent. Well, right now we have 10 liters of solvent. If we need to get to 15 liters of solvent, he's going to add 5 more. So I think this problem really isn't too hard. Once you nail down actual concrete values and you see what you know, what are you actually dealing with, and then you almost mentally walk yourself through actually doing what Lee is doing in this problem to figure out how much more solvent do you need for these things to be balanced. 45 says, for all x that doesn't equal positive or negative y, x over x plus y over x minus y equals what? So what do we even have to do in this problem? Let's make sense of that first. It starts out by saying for all x that doesn't equal positive or negative y, which is just kind of a weird thing to say. It seems almost irrelevant. But the reason it's saying that is because if x equaled y, well then x minus y, that would be like some value minus the same value, that would equal 0. And we can't divide by 0, right? We can't have 0 in the denominator. So x can't equal y, and x can't equal negative y, because if it did, then this would be 0. So it's kind of a weird way to start the problem, and honestly, it's kind of irrelevant. They have to put it there, but it doesn't really matter for anything that we actually have to do in this problem. So this is what they give us. And the first thing I noticed is we were dealing with two fractions and they're being added together. Now I remember from math class that if we're adding fractions, we need common denominators. Right now they're pretty close, but they're not the same. The first denominator has x plus y, and I'm going to put that in parentheses so it looks more like a factor, like one connected chunk. The other one has x minus y. So two distinct factors. So this first fraction, which has x plus y, well, it's missing the other factor, x minus y. So I'm going to put it in that denominator. But I can't just change the problem. I need to keep it balanced. So I'm going to put the x minus y in the numerator as well. So basically what I'm doing here is I'm multiplying the top and the bottom of the fraction by the same thing. And then in the second fraction, it had a y on top, and then it had x minus y on bottom, but it was missing the x plus y. So again, I'll just put the x plus y there, but I can't just put it on the bottom. That changes the problem. I have to put it on top too. And the reason it's okay once we do that is, again, if we multiply the top and the bottom of any fraction by the same thing, some number over the same number, that just equals 1. Right? So x plus y over x plus y also just equals 1. So it looks like we made quite a mess, but the first thing I'm going to do is just distribute this x into these parentheses and the y into these parentheses. So x times x would be x squared, and then we have a negative, and then x times y. Now there's going to be some stuff in the denominator, but I'm going to skip that for now. And then in the second fraction, x times y is xy, and y times y is y squared, and that was a positive sign between those two. If I was going to add these two fractions together, even if I just ignore what's in the denominator, it doesn't really matter right now because I know it's the same thing in each denominator. If I add the tops, these two terms would cancel out. Positive xy and negative xy would equal 0. So I would have x squared plus y squared on top. These two terms are the only thing left over. It's almost looking like that might be the answer. But remember, we do have a denominator to work with. So let's multiply x plus y times x minus y. Because I know I don't see this in any of the answers, so obviously I don't want it to look like that at the end. I must have to do something with it. And you might recognize that these are conjugates, and if you do, you know what's going to happen here. Two of these terms are going to cancel out. If you don't recognize that, that's okay. We end up with x squared minus y squared. So that's in the denominator, and so the answer is E. 46 says, Mary, James, and Carlos sold quarter-page advertisements for the school yearbook. Mary sold twice as many as Carlos did, and James sold 3 times as many as Mary did. What fraction of these advertisements did Carlos sell? All right, so the first distracting thing is this quarter here, this fraction. That's just talking about the advertisements that they're selling, so that has absolutely nothing to do with calculating anything in this problem. Mary sold twice as many as Carlos did. So if we take Carlos and multiply by 2, or how many things he sold, that would tell us how many Mary sold. So I'm just going to write that equation out. James sold 3 times as many as Mary. So James equals 3 times Mary. I'm going to think of it that way. What fraction of these advertisements did Carlos sell? So we're asking about Carlos, like C equals what? That's kind of what I need to know. Well, the total would be M plus J plus C. But instead of writing M, maybe I write 2C, because then that would be the same as this other C term. So 2C plus, and then instead of writing J, maybe I write 3M. But then instead of writing M, maybe I write 2C. So it's really just like a big substitution problem here. But now I've gotten all of this down to just C. Like the only variable I'm working with is C. So I have 2C plus, that would be 6C, plus 1C, so that would be 9C. So that's the total. So the total amount that they sold is 9 times whatever Carlos sold. And I don't actually know how many they sold exactly, but however many they sold, Carlos sold 1/9 of them, right? Because if we take that amount and multiply by 9, that would be the total amount. So Carlos sold 1/9. You could also just solve for C here and divide by 9, and then you'd see that the total divided by 9 is how much he sold. 47 says, in a window display at a flower shop, there are 3 spots for 1 plant each. To fill these 3 spots, Emily has 6 plants to select from, each of a different type. Selecting from the 6 plants, Emily can make how many possible display arrangements with 1 plant in each spot? Note the positions of the unselected plants do not matter. Okay, so let's visualize this, as I like to do with a lot of things. So we have 3 spots available, 1, 2, 3, for 1 plant each. So I can only fit like 1 plant, there's my plant, there's a little flower, in each of those spots. To fill these 3 spots, Emily has 6 plants to select from. So there's 6 choices that she could plant there. Only 1 will go there, but she has 6 things to choose from. Once she selects something there, she's only going to have 5 things to choose from for the remaining spot in the middle. And then once she selects something for the middle spot, she'll only have 4 things to choose for the last. And then it said we don't care about the other plants. So we're just doing 6 times 5 times 4. And that would give you 120.